So let's take example. So we know that we have to verify A to B gradient V dot dl. This is VB minus V. This we have to verify. Fundamental theorem of gradient. Fundamental theorem of gradient. So let's take an example. Now V is given as x square plus 4xy plus 2yz cube. This is V, and the point A is given as 0, 0, 0, and point B is 1, 1, 1. And we have to verify this along 3 different paths. So let's say first we have to move along the path. We have to move A to B along this particular path. 1, 0, 0. Then it is 1, 1, 0. And then it is 1, 1, 1. And next one is 0, 0, 1. We have 0, 1, 1. 0, 1. This value is 0, 0, 0, 2. This will be from 0, 0, 0 to 0, 0, 1, then 0, 1, 1, and finally 1, 1, 1. And third is the parabolic path. The parabolic path and it is given that z is x square. So this dependence is given. Again, you are moving from A to B, but you are moving along the parabolic path. Z is equal to x square, and y and x dependence is given. So let's see. Let us first check VB minus VA, because this integral value must be VB minus VA. So VB minus VA is given by V11 minus V00, and this will be 1 plus 4 plus 2 minus 0. This value will be 7. So if you calculate the gradient V dot dl from A to B along different paths, you will get same value. That we have to verify. If we can verify this, that verifies the gradient theorem. So let's find gradient V. So gradient V is given by 2x plus 4y x cap plus 4x twice z cube y cap plus 6y z square z cap. This is the gradient V. So now we will see path 1. So let us consider path 1 x, y, z. This point is A here. A is 0, 0, 0. Then this is segment 1. This is segment 2. And this is segment 3. So segment 1, you have to move 1, 0, 0. So this will be segment 1. This is segment 2. This point is 1, 1, 0. And then you have a segment 3. This point is 1, 1, 1, point B. So this will be segment 3. So along these 3 segments, we have to find the gradient V dot dl. We are moving from A to B along this particular path. So let's see segment 1. X is variable here, 0 to 1, but y 0, z 0. So this implies dy dz is 0. So dl is given by dx x cap. dl is dx x cap. So what will be gradient V dot dl? So gradient V dot dl will be 2x plus 4y dx, 2x plus 4y dx, and because y is 0, so this will be simply 2x dx. So this implies integral 2x dx x 0 to 1, this value is 1. So along segment 1, gradient V dot dl is 1 here. Now let's find along segment 2. So along segment 2, this will be given by x is fixed here. Now y is variable, y is 0 to 1 and z is 0. So again dx dz is 0. dx dz is 0. So dl is dy y cap. dl is dy y cap. So what will be gradient V dot dl? Gradient V dot dl is given by, this will give you 4x plus twice z cube dy, and because z is 0 and x is 1, so this is 4 dy. So integral 4 dy, y 0 to 1, this value is 4. So this is 1 and this value is 4. Now segment 3, we have segment 3. Along segment 3, x is 1, y is 1, but z 0 to 1 here. So this will give you dx dy is 0. So dl is dz z cap. dl is dz z cap. So what will be gradient V dot dl? So this is 6yz square dz, y is 1, so 6z square dz. So integral 6z square dz, this value will be z 0 to 1. So this is 6z cube by 3 and z 0 to 1. So this value is 2. So this value is 2. So it means A to B gradient V dot dl, this value is along segment 1, this value is 1 plus 4 plus 2. So 5 plus 2, this value is 7. So VB minus VA is 7 and gradient V dot dl A to B is 7. So that verifies the gradient theorem. And in objective question, if they have asked you gradient V dot dl, so no need to calculate this. Use the theorem and find VB minus VA. That will simplify your calculation. So let's see along second. Now we will find the second path. So second path is now again along different path. You have to move A to B along different path. So this is X, Y and Z. So this point is 0, 0, 0. Now this point is 0, 0, 1. Another point is 0, 1, 1. And then you should move to point B, that is 1, 1. So this is segment 1, segment 2, and this is segment 3. So again segment 1. So X is 0, Y is 0, and Z 0 to 1. So dx dy is 0. In same way, you can write dl will be dz z cap. dl is dz z cap. So what will be gradient v dot dl? So this is 6yz square dz, and because y is 0, so this will be 0. Now segment 2, x is 0, y 0 to 1, y 0 to 1, and z is 1 here. So again dx dz is 0. So this will give you dl is dy y cap. dl is dy y cap. So gradient v dot dl, that will be given by 4x plus twice z cube dy, and x is 0, z is 1, so this is 2 dy. So integral 2 dy and y 0 to 1, this value is 2. So along segment 1, integral is 0. Along segment 2, integral is 2. Now see segment 3. Segment 3, x 0 to 1, y is equal to 1, and z is equal to 1. So again dy dz is 0. So dl is dx x cap, because dy dz is 0. So gradient v dot dl, gradient v dot dl, this will be given by 2x plus 4y dx. So this is 2x plus 4 because y is 1 dx. So integral 2x plus 4 dx x0 to 1. So this value will be x square plus 4x and x0 to 1. So this is 1 plus 4 and this value is 5. So along segment 3, gradient v dot dl is 5. So A to B gradient v dot dl is 0 plus 2 plus 5 and that is again 7. So VB minus VO is 7, A to B gradient v dot dl is 7. So that verifies the gradient theorem. So we have verified along segment 1 and 2. Now we have to see along third path. So in general, dl is given by dx x cap plus dy y cap plus dz z cap. Now this dependence is given, z is equal to x square, y is equal to x. So we can write dz in terms of dx. So this is twice x dx and dy is given by dx. So we have to convert gradient v dot dl either in terms of x, y or z. So I am trying to convert it in terms of x. So what will be gradient v dot dl? So here you will get 2x. In place of y I am writing x. So this is 4x dx plus 4x and plus 2 z cube is z power 6 z x power 6. So this will be twice x power 6 and dy is dx plus 6 y is x, z square is x power 4 and dz is twice x dx. So now you should write this is 6x plus 4x. So this will be 10x plus 2x power 6 plus 12x power 6. So this is 14x power 6 dx. This will be the value. So now 10x plus 14x power 6 dx x0 to 1 because we are taking variable x. So from A to B, x varies from 0 to 1. So if you solve this, that will give you 10x square by 2 plus 14x power 7 by 7 x0 to 1. So this will give you 5 plus 2. So this value is 7. So again you are getting 7 value. So that verifies the gradient theorem. That gradient theorem is independent of path. It only depends on value of the function at endpoints. So we are moving from A to B along different path, but we are getting the same result. So that verifies the fundamental theorem of gradient.